Right, we've been talking about Pythagoras' theorem. Pythagoras' theorem, yes, like this. Pythagoras' theorem. We're not American. Okay, so I made the observation last time that when we have a right angled triangle here, if you've got side A and side B, this side C has got a particular fixed, well-specified value. I better put the right angle in there. Okay, so we've established that it's a particular value, and now we need to be able to calculate what it is. And of course, it's going to be some kind of formula. So this is Pythagoras' theorem, which is the most important thing in the whole of trigonometry because it crops up again and again and again and again. Okay, and it says that c squared equals, that's c there, a squared plus b squared. Let me just draw that a little bit more carefully. It's easy to get this wrong, so I'm just going to draw it again. There's my right angled triangle. You'll observe I'm drawing it every single time. I'm drawing it in standard format, which is kind of important. Put that there. There's my right angle A, B and C, and of course we are trying to work out what C is. We don't know what C is. So Pythagoras' theorem, a squared plus b squared equals c squared. A squared plus b squared equals c squared. Well, that's it basically. So you can write it as c equals the square root of a squared plus b squared if you want. We covered square roots and squares in the powers set of screencasts, so you can look at that if you want. But most people prefer to leave it like this because quite often you need the square of the distance anyway, so you just leave it like that. Okay, well, let's do some examples. Let's just draw my triangle here. 3 centimeters, 4 centimeters, and C. We need to know what the length of this side is here, this slanted side. We call this one the hypotenuse. Let's do that again. Hypotenuse, which is a rather grand word for this sort of triangle here. Okay, so we know that c squared equals a squared plus b squared. See, when I'm talking, I'll just write it out again and again and again. I'm not scared of that formula. I'm not scared of any formula because I just write it out. It's like talking about your worries. Once you talk about your worries, you think, not as big as all that, are they? And when you get a formula, write it down. Yeah? I've got people looking at me a bit oddly here, but there you go. Okay, so write it out and write it out and write it out again, and eventually you'll realise that there's nothing to be scared of. All right, so c squared equals a squared plus b squared, and we'll use these values 3 and 4 here. So a is 3, so that's 3 squared plus b squared. B was this one here, which is 4 squared, equals 3 squared is 9, 3 3s are 9, plus 4 squared is 16, which is 16, 17, 18, 19, 20, 21, 22, 23, 25. So we know that c squared equals 25. See that I'm not changing the left-hand side at all. I'm just fooling around with the right-hand side. So c squared equals 25. So what that tells me is c must be 5. Must be 5 because 5 squared is 25. So there it is. C equals 5. 5. There it is. Now, that's a nice simple example. Let's just go through that again. If I make a right angled triangle here. I'm trying to draw it as neatly as I can, but it's a little bit difficult with this tablet here. That's 5, 3, 4, 5. You call it the 3, 4, 5 triangle. It's the simplest non-trivial right angled triangle that there is. So let's just interpret that in terms of rectangles. If I make a rectangle, height 3, width 4, that distance there, this distance here, the diagonal equals 5. You'll observe I've got no units here. It could be centimeters, it could be light years, it could be feet, it could be inches, it could be microns, it doesn't matter. 3 by 4 triangle, a 3 by 4 rectangle has got a diagonal of 5, whether the units are centimeters or miles, or kilometers, doesn't matter. 3, 4, 5 triangle. In fact, before set squares were invented, people used to measure right angles in terms of getting a piece of rope that was 12 units long, 3 up there, 2, 3, 4 that way. This one was 5, and that constrains this angle here to be a right angle. Okay, there's the 3, 4, 5 triangle, which is our first application of Pythagoras' theorem, but I'm going to stop there. Okay.